Dear students, welcome to this session. In this session, we will look into the segmentation. What is a segmentation? Segmentation is it's a memory management scheme that support user view of a memory. The uh, the program is divided into many segments. So the program, whatever the program we have, all that is divided into different parts. Those are called as a segment. For example, the main program. So in our main program, whatever the program we have, there is a main program. There are certain procedures are there, certain functions are there, any variables. It can be local variables, global variables. There is a common block, a stack, a symbol table, arrays, or there can be any object or any methods. All these are divided. All these are considered as a segment. A segment is nothing but it is a logical unit of your program, and that program is considered as a collection of the segments. So this is the user view of a program. This is a logical address space. Inside the logical address space, the whole program is considered as a collection of different parts. So those are called as a segment. So for example, you have a main program, symbol table, stack, subroutine, sqrt is again it's a function, so that is considered as a segment. So the program is made into the collection of all these segments. So collectively all these segments make the program. So this is a logical view of the segmentation user space. In the user space we have these are the different segments, 1 2 3 4. These segments can be anything, like whatever the list I showed. These segments can be main program, it can be procedures, functions, objects, local variables, stacks, global variables. All those are considered as one segment, and each segment will have a one segment number. So this is a segment number 1, segment number 2, segment 3, segment 4, and these segments are mapped to the physical address. So you can see the segment number 1, so it resides on the physical memory space as 1. This is 2, 3 and 4. So the physical memory will have the frames. The segment 1 corresponds to the this frame, that is 1, and this segment 2 corresponds to the frame 2. Segment 3 corresponds to this frame 3, and segment 4 corresponds to this particular frame 4 on the physical memory space. Now we will see what is the segmentation architecture, how it is done. So first of all, the logical address will consist of two tuple. Okay, one is a segment number. In the previous slide we saw these are the segment numbers. Every segment will have a segment number, and also it will have a offset. So every logical address consists of a segment number and an offset, and we will have a segment table. In the segment table we will have it maps a two-dimensional physical address. Each table entry has a base and the limit values. And what is the base? So segment table, what is the segment table? The segment table will have the entry for each of these segments, and it will have two values. Those are the mandatory values that are required. One is the base value and one is the limit value. And what is the base value? Base contains the starting physical address where the segments reside in the memory. So base will contain the starting address of the physical address where the particular segment will reside. And what is the limit specify the length of the segment in the previous example. So the segment table will contain two important information. For example, for the segment 1, it will have the base and it will have the limit. The base will point to the starting address on the physical memory, and limit will specify the length of that particular segment. So that is what is specified here, base and the limit. And we will also have a register which will store the we have the segment table where this segment table is stored. That segment table information will be stored in the these two register: segment table base register, segment table length register. Segment table base register, STBR, it points to the segment tables location in the memory. So where this segment table will have an entry for each segment. It will have the base and the limit, and this segment table itself is stored somewhere in the memory. That the where it is stored in the memory, that location, okay, that segment table's location is stored in the this STBR, segment table base register. So segment table register, segment table base register will give the starting location where the segment table starts, and segment table length register, it indicates number of segments used by a program. Now segment table base register will give the starting address of the segment table, and segment table length register, STLR, will indicate how many segments are there that is used by the program. That information will be stored here. So whenever a segment is created, that length, the segment number would be less than the length for that particular program. So you can see segment number S is legal if S is less than STLR. So whatever the segment number we have created should be less than the value stored in STLR. So this is the address translation architecture. Here CPU, it generates the segment number and the offset, and the segment number will have a one is the base value and the limit value. What is the base value? This will give me the starting address on the physical memory, and limit will give me the length, how big is that particular segment. That length is given by the limit, and these values are stored in the segment table. So corresponding to this segment number S, we are going to find what is the limit and what is the base. So for every segment, so the program is divided into segments, and when CPU generates that address, it will have a segment number and it will have the offset. We took the example where in the program we have different segments: main program, functions, local variables, global variables, objects. All these are identified by a separate segment number, and D will represent how big is that particular segment. For example, main program, it is bigger, the offset will be large, so it will need a more space. Logical variable, it is very small, so offset would be less. So using the segment number, we find the base value and the limit value from the segment table. When we get this limit, okay, that limit and this offset, the offset whatever is generated should be less than the whatever the limit that is specified. If the result is true, if that particular condition is true, then what we do is we combine this base value with the offset. The base value with the offset will give us the address on the physical memory, and if this condition is false, that means it is trying to go into a address space which is not allocated to it. So that is a clear cut violation of the memory access. So that will result in a trap or a addressing error. So this is the example. In the example, you can see here, this is the logical address space of the users view. We have subroutine, a stack, a symbol table, main program, and SQRT. So our program is divided into these many segments. So this subroutine is segment 0, segment 1, segment 2, segment 4, segment 3. So our program is divided into total 5 segments. Okay, and these 5 segments will have a entry in the segment table. So for each segment there is a one entry. For example, for subroutine, segment is 0, 0, the limit is 1000, and starting address is, base address is 1400. Similarly for square root SQRT, segment 1, and the base address is 6300, and the size is 400. So on for segment 3, 4, 5. So not 5, segment 2, 3, 4, we have corresponding the starting address on the physical memory and the length or the limit of that particular segment. Now we will consider the segment number 0. So segment number 0, it has a starting address of 1400. So starting address on the physical memory is 1400. That is where we have the segment 0, and from there it has a length of 1000. You can see this is length is 1000, 1400 plus 1000, 2400. So the segment 0 resides in 1400 to 2400. Similarly, let us say we take the main program. Main program is segment 2. For segment 2, the starting address is 4300 and the size is 400. So you can see here 4300 is the starting address, and from there it has a length of 400. So 4300 plus 400, that is 4700. So that is the segment 2. Similarly, segment 1, 6300, and segment 1 is for 400, length is 400. So 6300 to 6700. So that is how the each segment is mapped to the physical memory.